Recall the word conjugate means two of the same terms with different signs between them. So complex conjugates are complex numbers a plus bi multiplied by a minus bi. And what happens when you multiply that is you get a squared plus b squared, because normally when we just multiply a plus b times a minus b, we get a squared minus b squared. But because there is an I as part of the term with the b, that's what changes this sign from minus to positive plus, because I squared is -1. So this is something that you can use. It's not necessary. It's not necessary to be able to multiply those together and get that. You could just distribute each term to each term and don't worry about this complex conjugate answer. But we do need a complex conjugate when dividing complex numbers that have two terms in the denominator, because division of radicals is just rationalizing the denominator. We learned that in chapter 10.5 on rationalizing denominators and numerators. Divide, then simplify if possible. Always write in the form a plus bi. For example, a, we first look to see if we can simplify by dividing factors, and we can't. And then we want to rationalize the denominator, because that's what divide means. It means rationalize denominator. Okay, so if we look at the denominator, there's two terms. That means we need the conjugate. So instead of a minus, this is 2 plus 3i, multiply to both the numerator and the denominator. And so in the numerator, we're going to distribute each term. 3 times 2 is 6. 3 times 3i is 9i. I times 2 is 2i. And I times 3i is 3 times I squared, which is -1. In the denominator then, like I said, you can use the complex conjugate if you want. Some people get confused on that, so we can just distribute each term. 2 times 2 is 4. 2 times 3i is 6i. -3 times 2 is -6i, and -3i times 3i is -9i squared, which is -1. So there's a lot of simplifying here. Let's start by multiplying the negatives. So that's just going to change the sign of that term there. Okay, and then we can combine like terms. So in the numerator, 6 minus 3 is 3. 9i plus 2i is 11 i's altogether. In the denominator, 4 plus 9 is 13. And 6i minus 6i cancels out. So this leaves us with this number here, but remember, it's got to be written in the a plus bi form. So the first thing I'm going to do is separate each numerator over the denominator. And that's something that we did in chapter 5. 5.6 was division of polynomials. So we can separate each term of the numerator over that single term in the denominator. And then we want to make sure it's in the a plus bi form, so the I is the second term there, and the fractions are both simplified. If we can't divide any factors, then that's all we need to know to say that that is the simplified division of those complex numbers. Then for example B, 6 over 5i, we want to rationalize the denominator. First, see if we can simplify the expression by dividing factors, and we can't. So I need to multiply by something to rationalize the denominator. Is 5 a rational number? Yes. Is I a rational number? No, it's irrational. It's because I is the square root of -1. So in order to rationalize the denominator, I need to multiply by another I, because I squared is -1, which is rational. So I'm going to multiply the same thing to the numerator. In the numerator, 6 times I is 6I. In the denominator, 5I times I is 5 times I squared, which is -1. So in the numerator, just 6I. In the denominator, 5 times -1 is -5. But this needs to be written in the a plus bi form. So which term do I have here? Is this a real number term or an imaginary unit term? And this is imaginary, so this is a -6/5 I. So what would our real number be? We don't have one because it's 0. So that completes the simplified complex number from rationalizing this denominator.